Hey, everybody, and welcome to today's explainer on the basic principles of MRI. We're going to dive into how magnetic resonance imaging technology actually visualizes the human body. And, well, spoiler alert, it all starts by looking at the absolute tiniest components of matter. It's a pretty wild question when you really stop and think about it, right? How exactly does a machine see inside your body, capturing these highly detailed images of your organs and tissues without making a single incision? The answer actually lies in understanding the motion of atoms. The way these invisible particles move and react is the hidden key that enables MRI technology to work its magic. But of course, to understand how they move, we first need to understand what an atom actually is. Section 1. Meet the atom, the building blocks of everything. So let's start our zoom-in journey, moving from the macroscopic human body right down to the microscopic level. The crucial takeaway here is that absolutely all matter in the universe is made up of atoms. They are fundamentally the smallest units of matter. You can't break matter down into anything smaller while still keeping its fundamental physical properties. If it exists as physical stuff, like the device you're watching this on, the air you're breathing, and yes, you and me, it's built out of atoms. Now, atoms themselves consist of three subatomic particles: electrons, protons, and neutrons. Each of these players has a specific charge and a specific location. Electrons carry a negative charge, and they orbit around the outside of the atom. Protons carry a positive charge, and neutrons, well, they have absolutely no charge at all. They're entirely neutral. And both protons and neutrons are located together right in the very center of the atom.
Section 2. Inside the nucleus, the dense center. Let's zoom even closer in.
While those negatively charged electrons are orbiting around the outside in sort of a cloud, the protons and neutrons live really closely together right in the center, which we call the nucleus. Because they share this incredibly tight living space, protons and neutrons can collectively be referred to as nucleons. It's just a handy umbrella term to remember when we're talking about the core of the atom.
Now, there's an extreme contrast at play here that's pretty fascinating. The nucleus is very, very small compared to the overall size of the atom, but it contains almost all of the atom's mass. To put that into perspective, if an atom were the size of a giant football stadium, the nucleus would be about the size of a single pea sitting right on the 50-yard line. Crazy, right? But despite being so tiny, the heavy lifting is all done right there in the center, because those orbiting electrons weigh practically nothing.
Section 3. Defining the elements. Atomic identity.
Knowing what's inside the atom is great, but how do we tell them apart? To identify different types of matter, atoms can be characterized by two distinct measurements: their atomic number and their mass number, which is also commonly called the atomic weight. You can think of these two metrics as the ultimate ID tags for every single atom in the universe.
Let's focus on that first one, which is arguably the most important for our explainer today. The atomic number is simply the exact number of protons in the atom's nucleus. The concept here is brilliantly simple. If you just count the positively charged protons hanging out in the nucleus, you get the atomic number. It's a direct one-to-one count, nothing complicated about it. So why does that simple count matter so much? Because this single number is the atom's ultimate identity, completely defining exactly what element it is. If you change the number of neutrons in a nucleus, you just get a variation of the same element. But if you change the number of protons, the atomic number, you literally change the element itself. An atom with 1 proton is always hydrogen. An atom with 6 protons is always carbon. The atomic number defines the element, period.
And this brings us right back to the magic of the MRI. Human tissue is made of specific elements, mostly hydrogen, and those elements are defined by their unique protons. So an MRI machine essentially listens to the motion of those tiny atomic centers to map out your internal structures. I want to leave you with a thought to ponder. If we can peer perfectly inside the human body without a single cut, just by understanding and tracking the microscopic motion of invisible atoms, what else could we visualize in our universe by mastering the secrets of these tiny moving particles?